Okay, TBS Math, this is Algebra 2, Lesson 3. Very short lesson, essentially a page and a half, and we're going to work through evaluation of expressions. So we're going to evaluate this expression. We are going to add like terms, and that'll be the second section of this class hour. So we are given in 3.1 an example with x squared y minus y, and x and y both are going to have values. X is going to equal to a negative 2, y is going to equal, in your textbook it says, a negative 4. So wherever you see an x or a y, you're going to put it back in this expression. So because we have negative 2 for x squared, and then we're going to multiply that by y, which is negative 4, and then minus negative 4 because we substituted y with this negative 4. Okay, what do we solve? Let's work on this part of it. Okay, we know that 2 negatives on this side is a positive 4, so we can leave that alone. Okay, negative 2 squared means negative 2 times negative 2, which is a positive 4 times a negative 4, which is a negative 16. Well, negative 16 and a positive 4 are going to wind up giving you what? Well, it's going to be a negative 12. And you will find that the answer in 3.1 is negative 12. Okay? All right, that's not the hardest algebraic expression. Now we're going to look at something like adding what's called like terms. Okay? And 3.B in your textbook tells us this. All right, I'm going to write this expression, 3xy, z, and I'm going to write this expression, 2z, y, x. Are these the same expression? And the answer is yes, they are. And the reason they are is because I can rearrange the letters, and each expression has the same letter. So if I wrote it in order, 3x, y, z, the first one's in order, and 2x, y, z. So these are similar. It doesn't matter if there's a negative or if they're positive, because what we're looking for are these variables, are they the same? Now, if I wrote 3x squared yz, is that the same term? And the answer is no, because x squared doesn't match up. So let's do a problem and see if we can actually tackle this and put it into practice, okay? So I'm looking at 3.3 on the bottom of page 34, and it says do this, simplify like terms. So they give us 3xy minus 2x plus 4 minus 6x squared. Excuse me, that is not correct. Let me erase this part of it. All right. Okay. So we have 3xy minus 2x plus 4 minus 6yx plus 3x. Okay, what are the similar looks? Well, let's start with the simplest. We have an x here, and we have an x here. Actually, we have a negative 2x and a positive 3x, so that just leaves us with x. Okay? Those two are done. There's no other number that looks and has a number without a variable, so let's just drop that 4 down here. That's done. Now, this expression and this expression are they the same? In other words, 3xy and negative 6, we could move this x and y to make it look the same. And yes, it is the same. So we have a negative, let's put this out front, 3 3xy. So our expression is negative 3xy minus x plus 4. And that's as simple as we can get it. And the reason is because we can't do anything more with these terms. There are no more x's, and there are no more just whole numbers. Okay? Not a real difficult concept, but again, going to be asked to do this quite a bit in your text. 3.4 is probably the hardest part of this text. Okay, so 3.4, they give you a problem, and it's 3a squared b over c minus 4b over a squared c plus 7a to the negative 2, c to the negative 1, b plus 4, oh nope, it's supposed to be a minus, sorry, minus 4ba squared over c. Now, what in the world do you do with this whole problem? Well, first of all, we want to make all the exponents positive, okay? So how do we do that? Or else we could put them all up on the numerator, okay? So let's just work on this one right here and put it all up on the numerator and see if we can cancel that out, okay? So we would do this by saying 3a squared b, that stays on top, but when we move this c up here, it becomes a negative 1, and that's all over 1, okay? Let's see if we have any other similar terms. If we move these up, we would have 4b a to the negative 2, c to the negative 1, all over 1, okay? Plus 7, and we want to make the exponents positive, so let's put a2, c down here, and we're going to leave b upstairs. For this one, you know what? Let's take these two, this a negative 2 and c negative 1, and let's keep it on the denominator. Okay, so let's put it down here. A positive 2, c to the first power, and let's get rid of that because these two are going to match this term, and this term are going to match. Minus 4b a squared over c. And again, we could put this one down here and call it c down on this side. Okay. So with that said, we can add basically like terms. Okay. 3a squared b over c, this term, and then 4a squared b over c, a negative 4. Those two terms can be subtracted. What about these two terms in the middle? Well, you can see that they are similar as well. You have a b on top in the numerator, the a squared c on the bottom. So essentially we want to combine these. So we're going to do this one and this one. Let's combine it, okay? And if we do, we have a negative 4ba squared and a positive 3, so we just have b a squared over c, okay? Takes care of this one and this one. And then here's a negative 4b and a positive 7b, so we have plus 3b over a squared c. Okay. Just totally missed something. Anyway, so that's how you combine like terms, and you can see that in the example problem that you have in front of you. Okay? All right, if there are any questions on simplifying and changing up, please talk to me. We'll do a couple of those questions in class together, but you're going to see 13 through 16, actually 7 through 16 is your new lesson, okay, about the new problems. So we'll work on those when you have questions about them. I think you should be able to get them without a problem. All right?